Hello class 9. Today we are going to learn about different terminologies of wave motion. We know when uh, the sound is produced, it creates a wave, and this wave starts uh, moving forward in this way. Okay, so when a wave of this type passes through a medium, there is there is some displacement of the particle in that medium which displaces this way. It moves up and again moves downwards and again it moves up, so it produces this kind of wave, and this wave is called as sine wave. Okay, so when this wave passes on through the medium, the maximum displacement means from here to here, this point is the displacement of that particle from its mean position. So this is the mean position. So it goes maximum up here and again comes down, maximum downwards out here. So its mean position will be this point. All right. So when the wave passes on, it has the maximum displacement on either side of its mean position. So this displacement, maximum displacement, is called as the amplitude. Okay, so the amplitude is defined as when a wave passes through a medium, the maximum displacement, the maximum displacement of the particle of the medium on either side of its mean position is called the amplitude of wave, and its SI unit is meter, and the amplitude is always represented as small a. So this is the amplitude. Now next, suppose if this is the wave and if we take only this much portion of the wave, that is from here starts, moves up, comes down and again comes back to its mean position. So its total vibration is from here to here and back to its mean position. Then it's called one complete wave or simply one vibration. So the time taken to complete this one wave or one vibration is called as the time period, which is represented as capital T. So the definition for time period will be the time taken by a particle to complete its one vibration is called the time period of wave. So to complete one complete vibration, the time taken is called the time period, and its SI unit is second. Next, uh, in 1 second, the number of waves. See the number of wave. Oh, this is the complete wave from here to here, and this is one wave, and this is another wave from here to here. This is second wave, and from here to here it is a third wave. Suppose let's say that in 1 second the sound produces three waves up till here. Okay, that means in 1 second there are three waves being produced. Then we say that the frequency of this wave is equal to 3. So the number of vibrations made by a particle in 1 second is called the frequency of the wave, and its SI unit is per second. That is 3. If the answer is 3, if the frequency is 3, then it will be 3 per second, 3 waves per second, or simply hertz. So we can say instead of per second we can say 3 hertz. So the frequency is represented by small f, and since the frequency and the time, they are related, the time duration, okay, so they are related as f is equal to 1 by t, where t is the time duration of the wave, time period of the wave, sorry. All right, next we have the wave, okay, and this portion, the topmost portion, is called the crest of the wave, and the downward portion over here, this one, is called the trough of the wave. So here this is there is a crest, there is another crest and another crest, there is a trough, another trough, another trough. As we have said that one complete wave is from here to here, so it has one crest and one trough. So a complete wave which starts from here, moves up, comes to the mean position and moves down and comes to its mean position. Up till here, it's a one complete wave. So from here to here, the distance from this point to this point, this distance is called the wavelength. Alright. Also, the same wavelength can be taken as from this crest to this crest, or from this trough to the another trough. Okay. So we can say that the distance between two consecutive crests or the distance between the two consecutive troughs are also considered as the wavelength of that wave. So the wavelength can be defined as the distance traveled by the wave in one time period of vibration. So in one time period, it travels from here to here. Alright, it travels from here to here. So that is one time period, and in one time period it completes one vibration. So one vibration, or the distance traveled from here to here, is called the wavelength. So the distance traveled by this wave in one time period of vibration of the particle is the wavelength, and its SI unit is meter. And the wavelength is represented by the Greek letter called lambda. So this is your lambda. Now, suppose if the wave travels in 1 second from here to here, okay, so from this point to this point, if the wave travels in 1 second, then this distance traveled by the wave in 1 second is called its wave velocity. So the wave velocity has the unit meter per second, okay, and that is the distance traveled by the wave in 1 second. Next we have the displacement time graph. So here we have, in our y-axis we have displacement, and on our x-axis we have time. So on displacement time graph, here this figure shows the displacement time graph, where this is your amplitude represented by small a for the given time, okay, and when this wave moves forward, okay, in time t, it produces the displacement time graph. Alright, and the time period over here is from here to here, that is from this point to this point, the wave is completely produced, and that time taken is called the time period, which is represented by capital T. Okay, so this is how we represent a displacement time graph for a wave. Next we have a displacement distance graph. So here this graph shows at an instant how a sound wave is produced. Here again the amplitude A, okay, shows how much the displacement has been done by the particle of that medium, and this is the wavelength that the wave has moved, that is the distance moved by the wave in its time period. Okay, so the lambda represents over here the wavelength of the wave, and also it can be taken from down there true to true. Okay, So it can be from crest to crest or from trough to trough. And this graph is the graph of displacement distance graph. So with this we come to an end. Just note down your assignment. Your assignment will be to make notes on these terminologies. Alright. Thank you.